Hi, and welcome to your second unit as part of Design Fundamentals, where we teach you various concepts, skills, and ideas that are key to creating beautiful designs wherever you go. Now, as part of this, what we are going to explore today is basic shapes and patterns. In your previous session, you saw how basic visuals could be used to create flowcharts and storyboards, but today we are going to go a little more hands on and creative and try to use shapes and patterns for our benefit. Let's begin with understanding what a pattern is. A pattern is a repeated decorative design where one or more elements or building blocks are repeated based on a rule that you have set. So, how does that work? Let's just say your block is something standard. Like it could be a basic shape, it could be something elaborate that has been carved. But the manner and frequency in which you repeat it, do you follow a grid? Is it organized? These are things that make up a pattern. And that rule, that repetition, is something you can decide. Now, you will see patterns everywhere around you, from the floor to the walls to the ceiling, and you will see it in modern places and in historical places. Patterns have been key to human design for the longest of time. You will see it every single place, and you will notice that these are not just your basic shapes. These are often shapes where a little something has been added, a little something has been removed, and some amount of magic has been added to it. So, basic shapes keep getting manipulated until they create a block, and that is the block that is used to build this particular pattern. Every single thing around us is made of these building blocks. When we see our own skin, it is made up of cells. When we look at our hair, it is made up of strands of hair. When you look at wood grains, it's made up of cellulose blocks. If you want to look at a building, it is made up of walls and doors and windows, all of them repeated in a pattern. Every single thing around us is made of building blocks. From the tiles on the floor to the bricks on the wall, everything is repeating units. Even phone production lines, all of them are repeating units. So today we are going to try and find out how those patterns can be cracked. But the repetition, the mode in which the repetition is done is what makes each kind of pattern different. Now, do you recognize these? I'm pretty sure all of you have learned them since your childhood. These are your basic shapes. You have anything from a line to a dot to a circle, a triangle, a rectangle, a pentagon, parallelogram. They can go on and on and on. But these basic shapes basically help in contributing to creating the building blocks that make a pattern. How do they work? Let us say I have a basic shape. Then I can add a little portion to it. I can remove a little portion to it. I can add another basic shape to it. I can remove a little more. And now I can add and remove until I have a design or a block that is capable of repeating. Whenever you combine these shapes in various ways, they can create patterns. And sometimes these patterns are regular, sometimes they're irregular, sometimes they follow specific rules, and sometimes you will see that they have a dynamism of their own. But how they repeat is what matters. How do they work? Mode of repetition is key. When you have a single unit and you can take that unit and decide how you want to alternate it. Do you want it repeating the same way? Do you want it multiplying? Do you want it dividing? Do you want it to alternate? How do you want it to repeat? Let's try with a simple example. If we have a shape, here I've taken a rectangle and I've turned it into a grid. Now, what I'm going to do is I'm going to cut a small arc inside this. I'm just going to draw a simple arc that way, and that is going to repeat across. You will notice that I've chosen a symmetry, both vertically and horizontally, for this pattern to repeat. The same arc has been hand drawn in every single piece. Now I'm going to make it repeat a little further. I'm going to add another piece of arc. Once again, this has followed the same symmetrical mirroring that I did in the first bit. Now I am going to add a new dimension, which is color. I'm going to take a piece of color and make this cut across the units that I've already drawn. Now, if you notice, the unit has basically cut across multiple units, and this color has created a unit of its own. Now, that makes it even more special because now the eye can see two different units. It can see a white color unit with lines, and it can see a dark blue unit. Now, you will see that the same coloring has been applied to all of the parts over here. At every point, you will notice that the symmetry is creating a work of art. And this is something that you can decide. Do you want it to be vertically symmetrical, horizontally symmetrical, radial, whatever manner of repetition that you want to achieve, that is something you can do. All you have to do is pick a building block and divide it into a pattern and start manipulating it bit by bit. While I've given you a very, very rough example over here, you will notice that as long as you're using skilled tooling work, it is possible to achieve something much more. Now, the pattern that you've seen developed in front of you is called a tessellation. A tessellation, simply put, is a pattern in which one or more shapes fit together so tightly that there are no gaps and no overlaps. How does this work? A tessellation is something that, let us say, if I've used a triangle to create something, then the gaps that the triangle leaves also creates a geometric shape. This way, a series of hexagons can work with a triangle, a series of squares can work with some other shape, and as long as there is no gap and no overlap and all the points meet geometrically, it becomes a tessellation. Now, the key point of a tessellation is because of its mode of repetition, it can go on endlessly. You will see tessellations even in nature. You'll understand that most of the things humans have designed have always drawn inspiration from nature. We are familiar with the honeycombs that we've seen. We're familiar with fingerprints, with the scales of a snake, with the wings of a dragonfly. All of these are things that nature already has, and humans have learned to mimic it. What we've done is we've taken something as simple as a tessellation and we've used it most prominently in architecture for the simple reason that tessellations are really great at being used geometrically. You'll see this both in historical architecture as well as modern. But now, have you noticed that sometimes in these patterns, shapes can also repeat into themselves? They need not necessarily be the same size. A simple shape following a simple rule can either move in, let us say if the first circle is 10%, then the next circle is 20%, then the third circle is 40%, then the next circle is 80%. As long as it's following a rule and it's repeating, it can either repeat outward into something bigger or it can repeat inward into something smaller. Now, this kind of a creation is called a fractal. A fractal is something where, let us say, we'll have another example. We start with a shape. Now, what we do is we add smaller versions to it. Once again, we add another smaller version, and so on, and so on, and so on, and so on, until the end result is a fractal. Now, this fractal is one where we have zoomed in, where everything we've done has become smaller and smaller. But we can take the same triangle and make it bigger and bigger and bigger. You will notice that this triangle can get bigger and bigger as you go. You can take the entire same triangle and continue to repeat it outward. So, how does a fractal work now? A fractal is basically a curve or a geometrical figure where every part has the same rule and character as the whole. Let us say if I have three lines, the quality of those three lines will be repeated in the next three lines that are added to it. And that is basically very typical to how crystals grow in nature, or how leaves grow on a tree, or even how the galaxy is formed. Now, you'll see fractals most commonly in nature. Let us take this shell for example. It begins with a very tiny arc, and the next arc is maybe 1.6% bigger. Then the next arc is again 1.6 times bigger, and every arc is progressively getting bigger and bigger as you go out, creating the shell we know. The same principle also helps the shell grow inward. That is, every arc goes progressively smaller as you go inward. And the same goes for crystals and even the leaves of a tree. Now, if you want to manipulate this as a human, you can come up with funky stuff like this, where basically, using tools that you already have, you can create a fractal that gets bigger and bigger or smaller and smaller using the exact same rule of repetition. Now, the tools that you have to be able to create all of this are again within your hands. Once again, you have your basic shapes. You have a square, a triangle, a pentagon, a circle, and a parallelogram. These are things that you can combine and repeat into tessellations and fractals based on rules that you have set as many ways as you want. However, you can also manipulate them. You can take a circle and you can make it more intricate. You can turn it into a flower, and you can take this flower and make that your repeating tessellation unit. All of these are things that you can do to create patterns endlessly. So now how will you create a pattern, a tessellation and a fractal? That's something for you to think about.